This is a screencast for a non-standard distillation problem in which we have a regular feed, but we also have a steam feed, and we are given the stage for the steam feed. It's on stage 1. So let's look at our problem. A distillation column is separating methanol from water, so methanol will be our more volatile component. The column has a total condenser and a partial reboiler. This means that the partial reboiler will be acting as an equilibrium contact, and the total condenser will not be an equilibrium contact. We know that the vapor stream is saturated and it is pure steam, so that Ys equals 0. Ys is the amount of methanol, the more volatile component, in the stream, and since it's saturated pure steam, it's 0. And it's input on the first stage above the partial reboiler, so stage 1. The top and operating lines and feed line have been plotted. Let's go to the next page and label these. This must be our top operating line. This is our feed line, and this line is our bottom operating line. So that's nice, those have been plotted for us. This red line is just the x equals y line. It doesn't mean anything. And then this curve is the equilibrium data. So it's the equilibrium curve. Let's go back to our problem. Determine the optimal feed plate location and the number of stages required. And we're going to be numbering our stages from the bottom. Let's first look at our column. We have the first top section, and this has V and L in it, and this will be the top operating line. And at the bottom we've got V bar and L bar, and this will be a bottom operating line. But let's note that we have a middle section, and this is going to have its own mass balance because it is in between feeds. So the vapor and liquid flow rates in this section will not necessarily be the same as in the top or the bottom, because we're adding some feed and we're adding some steam. And the addition of the steam is going to change the vapor flow rate. It's going to be V prime will be different than V bar because of the addition of the steam. And the feed, depending on what type of feed it is, will make V not equal to V prime possibly, and L not equal to L prime possibly, depending on what type of feed it is. If it's a mixture, then the vapor and the liquid leaving will not be the same as the liquid and the vapor entering, because you'll have to add some of this mixture of this vapor and liquid, if, for instance, it was a mixture. Let's just note what type of feed it is. Because the feed line is positive and greater than 1, we know that this is actually a subcooled feed. And you can review the sections on feeds if you do not understand why this would have to be a subcooled feed. What do we still need to do in order to determine our number of stages? Well, we have to figure out what this middle operating line is. And to do that, we will have to figure out what this feed line is for the steam. We already know what the feed line is because it's been plotted for us, and we know the top and the bottom operating line. What we don't know is the steam feed line, and then from this we'll be able to determine what the middle operating line is. So if this is pure steam, then Ys equals 0. The feeds are always plotted with the feed compositions, and so we know that this feed line is going to go through 0, 0. That is Ys, comma, Ys. Think about a regular feed, such as this feed up here. It will go through the point Z, Z. Well, it's the exact same thing for our steam feed. What's the slope of this line? Well, the slope is going to depend on the quality of the feed, and this is a saturated vapor, so it's going to be horizontal. That is, for a saturated vapor, Q equals L bar minus L prime over the feed. Because the feed of the steam line is all vapor, L bar equals L prime, and so this equals 0. The feed line itself has a slope of the slope of the steam feed equals Q over Q minus 1, which equals 0. So it's a horizontal line on the x-axis because ys equals 0. So our feed, our steam line, is going to be this red line. This is a little tricky because it's different than what we've usually done. Usually the second feed has had some sort of composition of the volatile component, so it's been somewhere higher on this x equals y line. But now because it's pure steam, it's going to be at 0 and a horizontal line. So our middle operating line is going to go through two different intersections. The first intersection is going to be the top operating line with the feed line. So this is the first point of where our middle operating point will go through. The second point is going to be the intersection of the steam with the bottom operating line. So the second point is going to be down here. So let's plot this. So this line is the middle operating line. And again, the middle operating line always goes through the intersection of the feed and the top operating line. We'll go back here. So the feed and the top operating line, and it goes down at the bottom through the intersection of the bottom operating line and the steam feed line. So those are our 2 points of intersection in our middle operating line. Now we will step off stages and we will start at XP, XB. So we will start here and step off. This first stage is going to be a partial reboiler. So partial reboiler. And you may want to go all the way to the middle operating line at this point, but it tells us in the problem statement that the feed enters on the first stage above the partial reboiler. And so we have to stay on the bottom operating line for the partial reboiler line. Now we go back up to the equilibrium line, and this is going to be the first stage, so we will move from here to the middle operating line, and we go up, and I have gone above the intersection of the middle operating line with the top operating line, so it's time to move to the top operating line, and we will continue stepping off stages as such. So we have partial reboiler, stage 1, stage 2, stage 3, stage 4, and stage 5. So the question asked us, determine the optimal feed plate location and the number of stages required. The number of stages equals 5. The number of equilibrium contacts equals 6. So it's 5 stages and a partial reboiler. And the optimal feed stage is number 2. And the only thing I want to add is that the steam does enter at the non-optimal feed stage. The optimal place for the steam to enter would be with the partial reboiler. So optimally it would enter at the bottom of the column instead of at stage 1.